So in continuation of the lecture 1, this is my lecture 2 on computer graphics, again unit number 1. So again we are considering the various applications of the computer graphics, areas in which computer graphics is used. So there are various areas in which we can use the computer graphics, that is the cartography, visualization of measurement of data, medical diagnostics, drafting, oblique computer design, preparation of applications, special effects in movies and in computer games. So first we will concentrate over what is the cartography. So cartography means whole process of mapping. In this case, we provide various maps or charts, that is the map of world. So in this case, we do the conception, production, dissemination. So far, other uses of the computer graphics in continuation of the earlier one is in CAD, that is called the computer aided design. It is one of the best software. So by using this software, we can design buildings, automobiles, aircrafts, motorcrafts, computers, textiles, and many other products. So far, we can do the practice for the design of various buildings as well as the mechanical parts. Even though we can also design various circuits using the AutoCADs. So this is one of the best software, and it is based on the computer graphics. Another use is in the presentation graphics. Nowadays we are using the computer graphics whenever we are going to present the things, or we are going to present the lectures, or we are going to summarize financial or the statistical or the mathematical scientific data, or we are going to design some sort of research reports, managerial reports, etc. So there is a need arise to use some sort of computer graphics packages. So there is a vast use in the presentation graphics. Another major role in the computer art, there is a big application of the computer graphics. So there are a few examples. Paintbrush. Paintbrush is very old. We can say the software. With the help of this paintbrush, we can do the practice, and the children can uh, do practice for making or developing the things using this computer graphic based uh, software. And similarly, there are other various softwares uh, for the mathematical software packages. Another thing is the commercial art makes use of art for logos, TV advertising, sports, page layouts, etc. So there is a wide, or we can say the vast application of the computer graphics. Another big role of the computer graphics in the entertainment. Computer graphic methods are used in making motion pictures, music videos, and TV shows. Even though currently we are developing or implementing a number of apps which we are running in the mobiles, uh, whether it is a Android based or iOS, some other operating system based mobile, but ultimately we are using the computer graphics. So there is a big role of the computer graphics, and ultimately we already know that everything is going to be online, whether it is a education and training system, or it is a banking system, or it is a medical system. Everything is going to be online in the coming time or in the future. So there is a very big role in the education and training, even though the example we can see currently everywhere there is a online education and the training is going on. Spatial systems are designed for training. That is, there are various file simulators for aircraft training, visualization. It is used in numerical model of a storm, modeling space shuttle, models of stream surfaces, etc. So there is a big role. So with the help of the computer graphics, uh, we can provide the better education to the children using the computer graphics packages. We can impart good experience uh, uh, in providing the training of the education. So we are also using, it is also one of the application of the computer graphics image processing. In this case, you are already aware, whenever you see a number of advertisement on the television, then there is a superposition system. That is, there are number of images which you can say superimpose, or uh, we do some image processing, so that the shape of the image change ultimately to the final one which we want to get. You can see the advertisement of the uh, two-wheeler, that is a motorcycle. You know, the motorcycle shape uh, change into the tiger. So first there is a tiger is running, and ultimately it changed into the motorcycle. So such type of things, we can do with the help of the image processing software. Similarly, there is a vast role of the computer graphics in medical applications. So everything is going in the medical with the help of various computer graphics packages. We can do various surgeries, and the training can be provided to the doctors using the 2D or 3D computer graphics. So we can see the various parts, various organs of the body with the help of the various software which are based on the computer graphics. Another big application as a graphical user interface. We are already aware. Currently, we are using various operating systems, and on the operating system, we are using a number of application softwares, and mostly application software are based on the graphical user interface, so that there is no need to remember number of commands. Earlier, we were using a number of commands, so there is a need arise that time to remember or to learn the command. Now, just by clicking on the image provided on the menu bar or on the left side of the computer, as we click on the image, then we get the output, we get the answer. We can uh, open the new file, create the new file, open the existing file, and we can alter uh, whatever we want. So, how this happens? This happens only with the help of the graphical user interface. So, if graphical user interface makes the software user friendly, even though the Windows operating system itself, it is based on the graphical user interface. So GUI are now common in software packages to allow fast selection of the processing. So a GUI usually comprises of icons, menus, buttons, and windows, etc. And there are various advantages of icons, so that we can, as we click, then we get the response. So no need to describe in the form of the text. Now, what is the aspect ratio? So the aspect ratio we use in case of various monitors. Earlier we were using the monitors which was based on the CRT, and nowadays we are using the LCD and the TFT monitor. But there is a need arise to define the aspect ratio. So what is the aspect ratio? It is the number of vertical points to the horizontal point necessary to produce the equal length lines in both directions on the screen. Then whenever we are going to choose the screen or the monitor, then we check the aspect ratio as well as the resolution. So there are two important things. First is called the aspect ratio and another is called the resolution. So what is the resolution? Resolution we can define as the sharpness and clarity of an image. So how we will get the clear image? It depends on the sharpness. So if the image is clear and sharp, then we can say the resolution is good. And we already know that there are 90,000 dots per square inch. Number of dots means number of pixels on entire skin. So a screen contains a number of dots means a number of pixels. So per square inch, how many dots? 90,000 dots per square inch makes resolution better, gives good pixels, gives clarity of the image. So whenever we are going to choose the monitor, then we always concentrate over the aspect ratio and the resolution. So the maximum number of spots that will be displayed without overlap is known as the resolution of the CRT. In case of the CRT, we can again define like that. Now there is a big role as a modeling. So we can implement or we can develop a number of models with the help of various lines. So there are Bezier curves, B-spline, box spline, simplex spline, polyhedral splines, quadrates, etc. So with the help of these, we can combine such type of different curves or lines, then we get ultimately a model. So the model representation can be done with the help of different type of curves. First one is the Bezier and B-spline and etc. So we can get a good image with the help of, or we can implement a new image that is called the model with the help of different lines and curves. So again, the examples of the modeling, it depends on physically based, also on material and procedural growth. So there are also the procedural models. Material based, metal, cloth, organic forms, fluids. Physically based, we see whether it is following the Newton's law or not, behavior as well as geometry we see. So we can design or implement various type of models with the help of the computer graphics packages. Now you can see this model. This is again, it is a model, but it is very difficult to implement such type of model. It is a part of the machine. It is very complex. You can see the shape. So why we are saying it is very hard? Because it is complex one, has typical shape, difficult to specify, and we also define in this case the realistic constants. What are the realistic constants? Detail versus concept. We compare this tedious and slow. Even though it is very difficult to develop, it is very tedious work, and then ultimately it is time taking, so it is also slow to develop such type of models. Why modeling is hard? So there are a number of challenges. First is called the mathematical challenge. Whenever we are going to design a model, then we emphasize over the mathematical challenge, computational challenge, interaction challenge, display challenge, domain knowledge constraints. Now we can see this is called the growth of models. So we cannot identify whether it is a developed model or this is a natural one. So we can implement such type of model with the help of different computer graphic packages. Now you can see again other examples of here we can develop such type of models which you are seeing on this slide with the help of various computer graphic packages. So again we are considering an image. For example, where did this image come from? What hardware or software did we need to produce it? So we are going to develop such type of, we are going to implement such type of image. Then what type of hardware or software needed? The hardware means we must have hardware to run the software. And what type of software needed? It is a software package which must be based on the computer graphics, so that we can use such type of software so that we can implement or we can develop a such type of given image. So this is very real one. You can see and look toward this. So there are various number of softwares. With the help of that, we can do the animated work of the rendering type of work. So first here is the application. What is the application? The object is an artist rendition of the sun for an animation to be shown in a domed environment. Software, what is the software? Here we will use the Maya software. Maya, it is nothing but a software based on the computer graphics in which we can develop 3D modeling. We can do all type of modeling. So Maya is a 3D modeling and animation program. So it is a program we can develop the animation that can be used for 3D printing and animated graphics for modeling and rendering. But Maya is built on top of OpenGL. So rendering means just we are going to change the image by superimposing various images. Hardware means PC with graphics card. Ultimately, uh, we must have a computer, maybe a desktop or the laptop, and there must be a graphics card. And nowadays, we are already aware there are also the inbuilt graphics card, and that are used for modeling and rendering. So there are various basic graphic systems. There are input devices, output devices, and image formed in frame buffer. So input devices, keyboard, mouse, etc. And there are also the output devices like the monitor. So the input goes to the processor, and the image is stored in the processor, and as it processes, it comes to memory. Again, suppose we want to update that, then it again goes to the processor, and ultimately image formed in the frame buffer. So in the frame buffer, the complete image formed, and then it goes to the monitor, and so that the display can be obtained ultimately on the monitor. So there is a need of the input devices, output devices, as well as frame buffer, including processor and memory. Now, what is the CRT? Earlier we were using the CRT, the monitor, which was based on the cathode ray tube. So we were using a heavy duty structure, that is the CRT, cathode ray tube. There is the electron gun and XY plates. Here there is a focus system. Electron gun produces the electron and it goes to the XY plates, and after that it goes to the screen where there is a coating of the phosphor, and ultimately we get the image on the CRT based monitor. So it can be used either as a line drawing device or to display contents of frame buffer, raster mode, that is called the. So the image we can store in the frame buffer. So this is the history of the computer graphics in 1950 to 1960. Computer graphics goes back to the earlier days of computing. Earlier we were using strip charts, pan plotters, simple displays, using AYD analog to digital converters to go from computer to calligraphic CRT. Cost of refresh for CRT too high. It is very bulky, expensive, and unreliable. Computers slow. So the cost of refresh for CRT is too much, too high. Now again from 1960 to 1970, we were using wireframe graphics, draw only lines, so that we can draw only the lines, sketch pad, display processor, storage tube, where we can store our image. So wireframe representation of some object you can see here. So this is only based on the different type of lines. Sketchpad, what is this? Recognize the potential of man-machine interaction. And actually, even Sutherland PhD thesis at MIT, and he used the sketchpad that time. So loop, display something, user moves light pen, computer generates new display. Sutherland also created many of the common algorithms for computer graphics. Now currently we are using various algorithms for the computer graphics so that we can draw the lines, draw a image, various type of curves. So for that there are various algorithms used in the computer graphics. What is the display processor? Rather than have the host computer try to refresh display, use a special purpose computer called display processor (DPU). So this is the now in the block diagram you can see host and then display processor. There is a display list stored here, and there is a mutual communication between the display processor and the display list, and ultimately we get the output on the monitor. So graphics is stored in display list, that is called the display file on display processor. Host compiles display list and send to DPU. What is the DPU? Display processor unit. So direct view storage tube after CRT. Again, there is a new launch that is called the direct view storage tube, and this was created by the Tektronix. So it did not require constant refresh. In this case, there is no need for the constant refresh. Standard interface to computers allowed for standard software, plot 3D in Fortran. We can use for the plot of the 3D. Relatively inexpensive. Open door to use of computer graphics for CAD community, so that we can easily draw the different types of buildings and the machine parts using the computer graphics. So this is the story of 1970 to 1980. In this case, we were using raster graphics, and this is the beginning of graphics standards. And that time we were using the workstations and the PCs. So there are different number of workstations and the personal computer. Again, now you can see the example of the raster graphics. This is the picture of the cat. So image produced as an array. Now in the another you can see, so the image of the cat you can see in the form of the picture elements. Picture elements, these are nothing but the pixels in the frame buffer. So pixels are stored in the frame buffer as a image. So here we can find there are in the second diagram there are number of pixels or the picture elements, and we can find the same one. So how we can develop or create or produce the image with the help of the raster graphics. Another example allows us to go from lines and wireframe images to build polygons. So with the help of the raster graphics, we can use different number of lines and wireframe images to build in polygons. Earlier it was only the number of lines. Now we can build with the help of the raster graphics. So it changes into the new one form. So PCs and workstations. What are the PCs? Personal computers. Although we no longer make a distinction between workstations and PCs. Historically, they evolved from different roots. Early workstations characterized by the network connection. So earlier we were using the client server model, high level of interactivity. And this high level of interactivity provided by the client server model. So that is called the network connection. So there are various number of PCs which were connected and form a network, and PCs acts as a workstation. Early PCs included frame buffer as part of user memory. So earlier we were using the frame buffer, and in that frame buffer we can store various images or the text. So easy to change contents and create images. So we can develop the new images or we can update or change. So you can see these images. Computer graphics 1980 to 1990. Realism comes to computer graphics. Now it looks like very real. Smooth shading, environment mapping, bump mapping. You can see. So there is a big role of the computer graphics to provide the realism. That is the actuality. What is the reality? You cannot judge whether it is a man-made or the natural. So you can see yourself. There is a big role of the computer graphics. 1980 to 1990, again, the special purpose hardware came into existence, industry-based standards, various software packages came into existence, network graphics, window-based, and then to human computer interface. Currently, we are again uh, doing a number of researches which are based on the human computer interface. So computer graphics in 1990 to 2000, in this period we were using OpenGL API, completely computer generated feature length movies are successful, new hardware capabilities, texture mapping, blending, accumulation, stencil buffers. So we can easily implement the movie with the help of the computer graphics from 1990 to 2000. Then the we can say the role of the computer graphic has already been started from 1990 to 2000. There is a big role. For computer graphics from 2000 to 2010, photorealism, then the photos or the images look like real. Graphics card we were using GPU, that is the graphics processing unit for the PCs dominant market. So in the PCs we were using the various graphics card. So it gives the real uh, graphics to the images. We can develop the real images. It gives the real reality. So game boxes and the game players determine direction of market, computer graphic routine in movie, Maya Lightwave. These are the name of the various softwares which we are using to provide the animation as well as in the design of the movies, programmable pipelines. Computer graphics from 2010 to till now. Now we are using in mobile computing, that is in iPhone or Android based mobiles. So there is a big involvement or there is a vast application of the computer graphics in the mobiles. Cloud computing, currently we are using the cloud computing. We are sending the files from one place to another. We can share the screen. We can change the desktop of other user. So or we can share the files with the help of the cloud computing. So we can do each and everything. We can change uh, everything on the other system with the help of the cloud computing. Virtual reality. What is the virtual reality? Virtual reality means what is going on. It looks like real. Okay, means the Earth is rotating. So Earth rotation, whenever you will see, then it looks like it is real. Means it is not happening in reality, but it is virtual one, and ultimately it looks like reality. In reality, it is going on, even though it does not exist. And artificial intelligence, now currently we are using, there is a big role of the artificial intelligence everywhere we are using, in the robotic system, in the other system, in the medical system, everywhere we are using, in deep learning system, or we are developing so much latest cars and the mechanical systems and electronic systems which are based on the artificial intelligence. So there is a big role uh, of the computer graphics this time. There is a big role of the computer. There is a big role of the computer programmer, the software engineer. Ultimately, there is a big role of different types of software packages. So at the end, we can say that uh, I will provide you a number of separate questions for your practice and also some multi MCQs, multiple choice questions, and you can do the practice for that one. Now I'm going to stop here.